Hey everyone, today we're going to be talking about the Medline data set. And Medline is a collection of journal articles that have been written in the United States and all of their associated citations. And this is maintained by the National Institute of Health. And I'm going to show you just really quickly what one of these looks like. You can see this is all, first of all, encoded in XML. You can see that there's an article title, there's some date information, all that kind of stuff. And then we can go down and we'll eventually get into these descriptors and descriptor names. And so they have words in them that are like keywords that are tagged in the article. So this one has, for example, behavior and congenital anomalies and disabled persons and disease and intellectual disability and so forth. So that's kind of how one of these journal articles works. So today what we're going to be doing is we're going to be building a graph. And the way we're going to build this graph is we're going to build a graph with each vertex being one of these topics. So personality or pregnancy, for example, will be a vertex. And then what we'll do is we'll use all of these documents. So if this document mentions pregnancy, and then the next document also has pregnancy in there, then what we'll do is we'll create an edge between the two documents. And so what we'll find is eventually we'll see how all of these terms relate to one another through the documents that describe them. All right, so this is an example where you can take a real-life problem, turn it into a graph. Sometimes it's not always obvious how to get things into a graph, and so I'm going to walk through that today. I know we kind of talked about that in the Boston data set as well, but with this one we're going to be doing something that's maybe just a little bit more real life. Okay, so let's get started. I'm going to start with this IPython notebook. I'm going to be using element tree today, and element tree is an interesting way to parse XML. And so what I'm going to do is I'm only going to work on one of the files in the Medline data set. If I were to work on all of them, this would quickly become a big data problem just because it's computationally very hard. It has way more nodes than my laptop could process. So we're just going to avoid that for now. Okay, so what I'm going to do is I'm going to use element tree to enumerate through this tree of XML, and I want to enumerate on Medline citations, which if we went back there, we would find out that's the typical root entry. And so for each of those, what I'm going to do is I want to go inside and I want to pull out all of their descriptor names. And I'm going to take all of those descriptor names and I'm going to put them in a topic list. And I'm going to ultimately come back with a tuple that is the article ID number and the list of topics that go inside of that article. And I'm going to append that to a list of tuples called citations. I'm also going to append all those topics to a place called topic list, and I'm using that so I can pre-build the pandas data frame that I'm going to put all this in. This should probably make sense in a second. Okay, so what I have when I'm done with this, I can just run these real quick. That one might take just a second. Okay. You can see that if I look at citations 0, you can see that I have here's article 0 and here are all the citations in it. All right, so now I need to build a matrix. I want to build a 2D matrix. And this is going to be my co-occurrence matrix. It's going to be all of the articles and then all of the keywords they mention. This is a lot like the Boston matrix we did. So the first thing I need to know is what are the dimensions going to be of this matrix. So first of all, let's figure out how long or how tall the matrix will be. That's pretty easy. All we have to do is figure out how many total entries there were in the citations list. And in this case, we're at 30,000 journal articles. So 30,000, done. All right, remember how I used topics up here? So I used topics as kind of a cheater. Topics has a list of every single word in it. And you can see there's 55,370 topics. what I can do is if I transform topics into a set, think of that as a mathematical set, that's going to eliminate all the duplicates. So then the length of that is 3,194. So that means there's 3,194 unique topics in our document. So we're going to need to make a matrix that's 30,000 tall and 3,194 wide. And I'm doing that right here. So I'm creating a pandas data frame, and I'm saying the index is going to be between 0 and 30,000. And then the columns are going to be the set of topics. And so you can see I've created that matrix here. It's 30,000 by 3194. And if we look at it, it's all empty. It's completely null. But you have all of these things like submarine medicine, or I'm not going to try and say that, but here's caffeine, and I can say that. And then we have here the document IDs. All right. So you can see that I can get at, for an individual citation, I can look at 1, which is the second part of the tuple, and I get a list of all of the topics. So here's the trick. What I'm going to do is I'm going to iterate through all of my tuples of citations, and for each citation, for each topic, I'm going to set, this is a little bit of tricky pandas maneuvering here. I'm going to go to, I want to go to the row that has the integer location of citation 0, and if you remember, citation 0 was this thing, the document ID, so I'm saying go to this row, and then what I want to do is for each topic in the list of topics, I'm going to say that topic, so for example, let's say it's vitamins, plus equals 1. That means whatever happens to be in here, increment it by 1. And so now, after that runs, what will happen is I'll have this filled in data frame now, where you can see these are no longer null. Now there's values in all of these. All right, so that's great, but it's 30,000 by 3194. And as you guess, I probably want to get to a topic by topic data frame. This is a lot like what we did in last week in Boston. So what I'm going to need to do is I'm going to first of all create a transpose, and so now I have a 3194 by 30,000 matrix. And what I want to do then is I want to, when I multiply two matrices, I take the dot product, I'm going to be left with a matrix with dimensions of 3194 by whatever is out here. Let me see. Let me try and explain that better. So I'll insert some text just about up here. So what I want is I want a 3194 by 3194 topic matrix. So to get that, what I need to do is I need to take the 3194 by 30,000 matrix, and I need to multiply that by a 30,000 matrix by 3194. And the reason I need to do that is because whenever you do matrix multiplication, these two inside ones have to match, and these two outside ones will be the dimensions. So what I'm going to do is I'm going to take co-occurrence transpose here, and I have the shape 3194 by 30,000. So I'm going to take the dot product of that and the original, and that gives me a 3194 by 3194 matrix. All right, so this is my co-occurrence matrix. You can look at it if you like. Here it is. And you can see that here's the matrix. Something kind of weird is this particular diagonal, right? This just is the count of the total number of times this keyword was present in the overall set of documents. All right, so what I'm doing here is I'm going to take this co-occurrence matrix and save it to CSV file here. And that's because if you are to run this code on your own, what you're going to find is that this transpose and this multiplication takes quite a long time. And so what I want to do is I don't want to ever have to do that again, so I'm going to take this, this transformed data set and save it to a CSV. Okay, once that's done, I'm going to go ahead and I'm going to continue my work on a new IPython notebook, and this is going to be called Medline Graph 2. All right, and so what I'm doing is I'm reading that co-occurrence matrix back in. This is a new file. So I'm reading it back in with pandas, and you can see that I have it here. It's all good to go. It's exactly what we saw before. And then this is pretty much the same as last week. So now that we have this co-occurrence matrix, we can create a graph from it. All right, and so then once we do that, all we have to do is draw that graph. So I took the exact code from Boston here, and you can see I even left the Boston name in there. But the problem is that you can't read this thing. It's a great big mess. And so it's really hard to do anything with this graph. All right, so I'm going to make another quick video, and in my next video, I'm going to use a tool called Gephi, and Gephi is what I'm going to use to visualize this graph and do something useful with it. Because I think we've really, when we get into graphs this large, we've kind of hit the limit of what we can do that's useful inside of NetworkX. All right, thanks for listening, and I'll talk to you in just a second on my next video.